All right, well, what I'll do, so we'll kick off now. So we said we'd start at 11 o'clock. The session will be recorded, so there'll be an opportunity to send this out afterwards if there's anybody that needs a recording. The goal today will be I'll do a very quick introduction, and then once, if there's any questions that get asked during the session, what I will do is I'll capture those, and we can always ask those at the end. But I'm not going to open up audio because I think that can sometimes get a bit messy. So if there's any questions, use the chat or the question option within GoToMeeting to ask them, and I can pose them to the team at the end. But otherwise, we'll kick off. So today we've got myself, Mark Jolly from APPTechnology, and we've got Barry Daniels and Michelle Laverick from Droplet Computing. And obviously, I'm going to go through two quick slides. The reason we're here today is there's two major things we're looking at. So one is we're aware in the marketplace that there are still legacy applications out there, and these can be out there for a number of reasons. There can be applications where there's no upgrade path. So particularly I'm thinking sometimes applications that are tied to machinery in a manufacturing area, or sometimes in hospitals. Sometimes there can be applications that are just costly, they're bespoke, and to redevelop them it's just not financially worthwhile. Similarly, sometimes there's no business benefit to upgrading them. They do exactly what they need to do today, and upgrading them to the latest version can cost a small fortune. And actually, it's perfectly functional. It's just an old piece of software, and therefore has support challenges. And equally, we find often that there are applications that are due for decommission, but that have been due for decommission for a couple of years, and they're still due for decommission, and that couple of years is sort of almost ends up being rolling and rolling and rolling. So Droplet is a great solution for that, and it allows you to provide a secure platform for those applications in your environment. But also, what we've seen recently with the Windows Virtual Desktop platform, it provides a really quick capability to set up a scalable infrastructure in the cloud. But with conjunction with Droplet, it allows you to then potentially take that legacy application, both resolve the security challenges and move it to Windows 10, but also potentially to move it to the cloud, which takes that and makes it a much smarter application for deployment. So with that said, what I'd like to do is hand over to Barry. Barry will tell you a little bit more about Droplets and the technologies, and then we'll hand over to Michelle at the end for a demonstration. So let me pass over to Barry. I'll make you the presenter. Now, Barry, you're showing us Michelle twice. I don't know which one of you it is.
Okay.
Let me pass. I'll make the first one a presenter, and we'll see if that's you picking it up. If not, I'll shift it to
that message. So I'll say not yet.
Okay. In which case, there we go.
Okay. Hopefully you can see a screen.
Yep.
And you can see the presentation on that screen.
That's right, yep.
Excellent. Let me go into slideshow mode. I'll just flip that. I'm guessing that's got a swap. Yep, we good?
Perfect.
Wonderful. So Droplet Computing, we're a container technology. When we say containers, everyone instantly thinks of Docker, obviously with Kubernetes. We're not that. We're about divorcing the applications away from the underlying operating system, putting it into our container technology, wrapping a security blanket around it, and then allowing you to deploy that across platform where it needs to run. Docker, on the other hand, you more all around DevOps and controlling cost of cloud, having multi-aware applications that you can spin up on demand, shut down on demand. So a different take on the whole container piece for us. We are patented worldwide, so no one else can do what we do. It's ideal really for the legacy application challenge we're going to talk about today in conjunction with sort of the WVD and the guys at APPTech here, who are one of our primary partners. So excellent for going forward, selling what we sell, which is security, compatibility, and compliance ultimately. We've won a couple of awards as a company. We're the only company to actually win back-to-back awards from the British Computer Society. This year we were a finalist. We couldn't make it the triple, unfortunately, in specialist vendor, but it was still nice to be recognised by our peers, especially when we had platinum sponsors in our categories on both years. Now, we do go cross-platform. Today, we're going to focus around Windows Virtual Desktop, but it was important to say that we do run our containers across multiple different operating systems, whether it be Apple, Windows, Linux, Chrome, as well as obviously into the cloud, which we're going to talk about today. And this was what Mark was alluding to, really. The challenge that you have out there typically is because the legacy applications are tied to an older version of .NET or Java, or an old version of IE that's running, that's now seen as insecure, not compatible, end of life on support, because they're tied to those legacy operating systems. And so Windows Virtual Desktop is a great way of moving that forward. But then how do you get your legacy applications there? Well, Droplet is that answer. And the good news is the way in which our container technology works, we don't need any recording, capturing, sequencing, or packaging to get your applications inside our container technology. And there's no back-end infrastructure needed either. So there's no additional costs involved with getting your apps to the cloud. Security is a big part for us. And although we run on all these different operating systems and in the cloud, we take security seriously, and we don't rely on just us saying that we're secure, because the biggest challenge you're going to have with these legacy applications is how do I secure them, because of the vulnerabilities they by nature have, either on that older operating system or the actual binaries of the tech itself. We wrap this layer of security around. We went to the NCC Group PLC to be pen tested, and we put some really insecure things inside our container. So it was IE8 running an old version of Java, 1.6 it was, through a JInitiator app that really would be very vulnerable. And we said to the NCC Group, go ahead, do your worst, go hack. They couldn't hack from outside of the container, outside of the system. What we're going to talk about today in the context of WVD, obviously that would be the perimeter defense. So you'd have a patched and up-to-date operating system as the first port of defense. And we are just an app to run an app. We're a wrapper inside of the layer of the operating system itself, even though the application is divorced away from any dependency of that operating system. We then took it a step further. They then took a compromised host machine and tried to crack into this vulnerable software from inside a compromised host, and still couldn't actually get inside the host. They did bring one advisory up on the last round of pen tests. They said, we know we couldn't hack inside, we know we couldn't get access to this vulnerable stuff, saying we could have. We noticed you don't block any outbound ports outside leaving the container, as we talk through the host device to the network, so you can still connect back to database servers, network drives, etc. And they said, look, you don't block any of those outbound access. So we added an additional layer of firewall control for the end user to configure and bolt down the traffic that leaves the container. So you could configure it to only speak to a set IP range, a port number range, or a specific database on a certain IP and port range. And this is how we operate. So we have an executable that's deployed across the platform of choice. So today it'll be the Virtual Cloud Edition that runs on Windows Virtual Desktop that we have. And that takes care of the compatibility layer for us and talks from the host system to our container and enables that bidirectional traffic to be translated via our software. And then we attach the actual container image itself that bolts onto that application. And this can be deployed very simply. You create central golden image of either the DCIX or the DCIM. It depends on the binaries you need inside your container. It could be that you have really, really old DOS apps or XP type apps, in which case you use the DCIX container, or it can be for more modern applications. So something that would be from Windows 7 to Windows 10, for example, or later, that we can deploy via the DCIM image. And when locked inside that, you create your policy engine, you create all of the governance inside one centralized image, and then you can deploy it once created 100 times, 1,000 times. It scales particularly well. So it's a very similar architecture to a lot of you will be used to around VDI structures, where you create a central gold image and then deploy that image out across. I'm going to hand over to Michelle now, who's going to talk you through a little bit more of the technical side and then go into a demo. So over to you, Michelle.
Thank you very much, Barry. So in a WVD environment, we do support two different runtime modes, a user mode and a service mode. In the user mode model, it's the user who starts up the container. And this works quite well for environments where the application that's being containerized is used relatively infrequently. For example, just once a day for an hour or so, or once a week, once a month, or once a quarter for some sort of batch process, or indeed a situation where you need access to a legacy-based system just for compliance or audit reasons. For applications that are used every day, all day, highly frequently, we would actually recommend using our service mode. Now, in the service mode, the container starts when the WVD instance starts, and it services up applications for many users. So the decision to go either user mode or service mode really is about how you use the application and whether it's something that's used frequently or infrequently. In terms of those different runtime modes, in the per user mode, which gives you maximum flexibility, each user gets their own container and they can customize it, modify it, do whatever they like with that particular container, albeit within the constraints of any security policies that you obviously put in place. So it's highly flexible in terms of where the user uses that container. In the per service mode, you try to imagine just like how Microsoft has allowed Windows 10 to be multi-session, like our old style terminal servers or RDSH hosts, the container inside that virtual desktop pool can also be multi-session. So multiple users can connect to the same Windows 10 desktop, and multiple users can pull out applications out of the container. So the model on the right scales very, very well for high densities of users and high concurrency rates. And if you're trying to meet pretty tight TCO style investments and make sure you get maximum bang for your buck, then often that's the mode that a lot of customers go with, the multi-session per service mode. In terms of the resources that are available to the two different modes, we tend to go with the 32-bit container in the per user mode, which has a maximum of 2 container CPUs and 4 GB of memory. Often you can actually get away with not configuring the maximums, but configuring the minimums around 1 CPU and 2 gigs of RAM per user. And then on the right-hand side with the per service mode, we tend to lead with the 64-bit container, which has a massive 4 container CPUs and 192 GB worth of memory. So basically you can carve out of your Windows 10 instance a chunk of memory purely for supporting your legacy applications based on whatever the concurrency is of the users or how frequently they'll run those applications. After all, if they're not run that frequently, you don't have to assign that much memory.
Okay, I'm going to hopefully change presenter to you.
Thank you very much.
Excellent. Yeah, we can see.
You see my screen. Okay, let me just get rid of
Yep.
some effects here. So this is a Windows 10 virtual desktop running in Azure. In the bottom right-hand corner here, you can see our little droplet icon, and this is the main droplet application. Now, for the most part, users don't actually interact with this application at all. It's usually minimized. In fact, even that icon can be made hidden in Windows. And what they actually interact with is something we call a droplet seamless app. This is a droplet seamless app here. And as you can see, it floats in the desktop environment. The end user really has no idea that the application is running in the container. They just double click a shortcut on their desktop and that application opens up. Yeah, they could have done that from our main launch pad, but what we've tried to do is reduce the footprint of the application, and so the user doesn't really have to integrate or interact with this particular front end at all. It just sits hidden in the system tray, ready to receive applications from the end user. This front end, therefore, is more like a friendly management front end for the administrator. When it's locked, end users really can't do anything except launch an application from this UI and little else. Really, it's the administrator that's probably going to interact with this more, usually during the process of building the very first container. And when I say building, I basically mean installing software into it. There's nothing really to build. You install our software, license it, start up the container, and start installing applications to it. So I've got two things I really need to show you. Firstly, how this UI on a per user base controls what the user can and cannot see. So if I unlock the container, clearly in this container there is a lot more than just two executables, excel.exe and notepad.exe. There are literally hundreds of executables inside the container, as well as Microsoft Word and PowerPoint and all the other things that make up this legacy Office suite. So if the administrator needed Michelle here to have access to an additional application, it would be very easy for them just to create a shortcut, essentially, what we call an application tile. All that's required for that is the name of the application and the name of the executable. Optionally, a ICO file to create a pretty icon on the user's desktop. If this is left blank, what they will get instead is a droplet icon on the desktop instead. Some of our customers actually quite like just using the droplet logo. It makes it easy to identify which apps are running from the container and which apps are running from what other application delivery systems you use, not least just installing the software into the to the Windows 10 environment itself. So if I do a double click at that application icon, there's my copy of Word. In my demos, I tend to use a legacy Office application like this, mainly because we all recognize these applications. This is Office 2003, so it's some 14 years old. But mainly what we find running in the container is usually some kind of line of business critical application that is wedded to and embedded into the organization's operations. And either it's impossible to replace, or its replacement, because it was quite old, has been delayed or pushed back or cancelled, or for whatever reason that project is taking longer than it was originally intended. The last thing I want to show you, so we've obviously got a small amount of time today, is how easy it is to install software inside the container. Once the container is unlocked, we expose a toolbox of utilities that allow the system administrator to do an installation. And what I've done is already copied a very small installation program to the downloads folder just to save some time in this demo. And I'm going to run that as the administrator. As you can see, there isn't really a packaging, sequencing, recording process to Droplet. Installing applications into the container is just the same as if you were installing them to a particular PC. Yeah? In fact, if I minimized both of these windows, you would think I was actually installing this software into Windows 10, but I'm not. I'm actually installing it into the Droplet container. So even our installation routine is pretty seamless to the administrator. So the key thing really about installing applications into a container is knowing what your dependencies are. So, do you need .NET? Do you need a particular version of Java or something like that? Does the application need configuration files or registry changes made to it in order for it to function? And that's where the real work happens, just understanding your own applications and its requirements. So that app has now been installed. There's Notepad++ inside the container. I can double click at that and just run that executable. Of course, the better thing to do would be to create an application tile for this application to make it easy for the end user to gain access to it. So again, that's a relatively straightforward process. I just need to type in a friendly name and also the name to the executable. Optionally provide an ANCO file. Next and finish. That will dump a shortcut on the desktop. I can now lock the container and minimize it. And then I can run the droplet icon here to run Notepad. Yep, so the user really has no idea about how the application got delivered. It just magically appears on their desktop. Let me just speak very, very briefly though about what's going on underneath the covers here. There are some small metadata files that appear in the user's profile. This admin front end is nice when you're initially building, but if you want to deploy this at scale, you don't really want to be interacting with this graphical UI for every single user. Fortunately, in the world of Droplet, everything we do is just a file. So in my profile here and in the Droplet folder, I have things like the apps.json, the credentials file, the license file, and what's called the end user license agreement accept. Those are only the files I need in the world of WVD. Yeah, so when the user logs on, as long as those files are created in this directory in their profile, the next user to log on into the WVD environment will get exactly the same experience. And if you think about that as well, as it's just a file, I could have many apps.json files on my network, and as Harry logs in, he would get his apps.json that might show 6 applications, but when Judy logs on, she gets an apps.json that's associated with the fact that she's a member of the accounts department, and she gets 8 icons. So this apps.json file is really the text front end for this graphical UI, making it very easy for the administrator to create different looks and feels and different icons programmatically made on the user's desktop. So with that, I'm going to hand back to the main presenters. Shall I hand back to you, Mark? So
yeah, absolutely. Actually, Michelle, if I was going to say, actually, if you left your screen open, it might be that we need to demo something else, but I'll flip back to me for now.
Sure.
So I've obviously, if there's any questions that people have got, you can ask them in the channel. I've had one question already asking about hardware connectivity. So for applications that might need USB or serial connectivity. So Michelle and Barry, I don't know if you've got a response on how Droplet handles that.
I can speak to that. We do have a USB edition, and we also have support for serial, COM ports, and LPT ports. That serial and COM port and LPT port is built-in feature to our product. By default, these redirections, as we call them, are turned off. We take a security standpoint of or posture that all the doors are closed until the administrator opens them. But a simple change to a text file to enable serial and COM ports is all that's required. And that's a feature that's out of the box, built in, no special licenses are required. Obviously, in the context of WVD, access to devices like USB and COM ports might actually be restricted by the policies or the way that the WVD environment has been set up. In most cases, what we find is in engineering, like automotive, aviation, and things like that, where these sorts of devices are needed, a lot of the engineers will actually carry their own laptop and their own Droplet container used to do that sort of servicing and management. So I think in terms of hardware devices, you should always look to the platform, in this case WVD, and make sure it's capable of delivering that infrastructure or that hardware requirement before going down that route.
Perfect. All right, Michelle, I've not had any other questions flagged up. So what I'll do is, the intent was for this to be a short and sweet and snappy webinar. Obviously, for everyone that's joined, we'll follow up with you after this. And if there's any specific questions you've got at that point, then we can take those up individually. But I'd just like to thank, firstly, Barry and Michelle for helping run the session today. And for everyone who's joined for taking the time to join. And I'll be closing the call now, and hopefully that's 5 minutes back in your calendars either ahead of lunch or your next meetings. So thank you ever so much.